Okay, this is going to be the last part that I'm going to do on the semester review. I will stop at number 65. The part after that is Chapter 9 review information. In fact, it's the same problem. So look at the Chapter 9 questions on the video. But before I even start doing some of these quadratic problems that we did way back at the beginning of the semester, I want you to remember this model here. When you have a path of your parabola, this is going to be P and this is going to be Q because those are your two roots. So, for instance, if we take a look at this problem number 56, this problem really is written in intercept form or root form. Okay, so if you recognize that this actually is an intercept form, okay, third try, got interrupted twice, but let's see if we can't do this. So if you recognized that this equation is actually in intercept form, because this is like x minus 0 for this piece here, and this is x minus 260. So what does that mean? That means that 0 is your p, and 260 is your q. So that means this is 0 and this is 260. And so if you want to know the total distance that the golf ball traveled, well, that went 260. Now, I also want to tell you the other parts of this parabola. This is the x value of the vertex. And you get to here by doing your negative b over 2a. This is also the h value if you have this in vertex form. Now, what's this up here? That is your y value of your vertex, so that's your height. It's also your k value if it's in vertex form. And how do you get the y value of the vertex if it's in standard form? You plug the x value of the vertex into the equation. Okay, so some people might have done this an alternative way, which I don't suggest. It's harder. But if you did not recognize that this is actually in intercept form and you multiplied this out and you got this, okay, so then you say, okay, that's standard form, and this is my A, and this is my B, and C is 0. Then you would find the x value of the vertex by doing negative b over 2a. And you would find that that's at 130. See, so our x value of the vertex is 130. But again, since this asks for the total distance, that's all the way over here. And so you have to double that. And so 2 times 130 gets you all the way across at 260 yards. Okay, so you have to know this anatomy of this parabola. You have got to know where all of the x value of the vertex, your roots are, your y value of the vertex, all of that kind of stuff. Okay, number 57 is different. It's not a parabola, so let's take a look at that one. This one is saying you are given an equation, a profit equation, and we have a profit of 96 million. This profit is in millions, so I'm just going to write that as 96. Okay, so I'm going to subtract this 96 over to find out where my solutions are. Now, I can't factor this thing right here, but I do know that 2 million is one of the solutions. So if I know one of the solutions, what can I do? So 2 million is a solution. So I could divide that solution out. So I'm going to do that. This is my x cubed. There are no x squareds. Here's my plain x's, and here's my plain numbers. I'm going to divide out the 2 million, which I know is a solution. I'm going to divide it out synthetically. Multiply. And see, it comes out with a remainder of 0 because, and it should have, because I know that that is a solution. So now I'm going to take this, and I've got negative 6x squared minus 12x plus 48 equals 0. Now, I do not like to have my leading coefficient negative, so I switch all the signs. And now I'm going to factor that. When that factors, it factors as 3x plus 12, 2x minus 4. So therefore, I can tell my solution here is negative 4. My solution here is positive 2. Now, the question says, show that 2 million is the only production level that the company yields a profit of $96 million. Well, can they make negative 4 million DVDs? No. And then this other one is a 2 also. So given that 2 that was given to us plus the 2 that we solved for, I have shown that 2 million DVDs is the only way they can have a production level of 96 million. Physically, what's happening on your graph is this. You have something like you have a cubic, and this is your 2 million. This is your negative 4. So if you brought your production line to here, then this is the only way here that you can have that production. 58. Okay, we got the dimensions of a stage are 30 by 15. And we're going to add x to the length and x to the width. Okay. So then this distance here is 30 plus x. This distance here is 15 plus x. And it wants to have a new square footage of 1,000 feet. Square feet. So I FOIL I bring this 1,000 over. And so then what I have is, and I'm going to go ahead and, well, I've got this here, negative 550 plus 45x plus x squared equals 0. If I rearrange that and I factored it, it would factor as x plus 55 and x minus 10. And so therefore, negative 55 or 10 would be the distances of my x. And I don't want a negative distance, so this one doesn't work. Now the question says, what are the dimensions of the new stage? So 30 plus 10 is 40. And 15 plus 10 is 25. So it's 45 by 25. Those are those new dimensions. Okay. Next, number 59. The volume of the rectangular prism can be expressed as the particular function that was given. And it got put onto the other page. 4x cubed plus 8x squared minus 9x minus 18. Okay, so that's the function of the prism. And they say that x plus 2 is the length and 2x minus 3 is the width. And the question is, what's the expression of the height? So I'm going to divide out one of my solutions. And so I'm going to synthetically divide. Here are my coefficients of my function. And then I'm going to put the solution here, which is negative 2. And I'm going to divide that out. And I should get a remainder of 0. I do. So this is 4x squared minus 9 equals 0. And how would I factor this? Well, it's a difference of perfect squares. So it's 2x plus 3 and 2x minus 3. And since 2x minus 3 is already the width, then what does that mean the height is? So therefore, the height is 2x plus 3. Okay, number 60, we want to know the height of this baton, and you can see this is a quadratic, so therefore we have a parabola. It's a negative quadratic, so we have a parabola. We want to know this height. So that's the y value of the vertex. So how am I going to get that? Well, if I figure out the x value of the vertex, which is negative b over 2a, plug it back in, that'll give me that y value of the vertex. So there's a, b, and c. So my x value of the vertex is negative b over 2a, and that ends up being 1. Plug that back in to get the y value of the vertex. And that answer is 22 feet high. Okay, now 61, we're starting now talking about our our exponential functions. Remember that with our exponential functions that our growth model says this. There's our starting amount that we started with. And then our growth is going to be 1 plus or minus the rate for however long. Now, if it is plus, then we have growth. If it is subtracting away from 1, then we have decay. So adding the rate gives us growth. Subtracting the rate means we have been decaying. So if this says we start with $1,200 and we decrease by 30% per year, that's 0.30. Write an exponential decay model. Well, that would be this. Y equals our 1,200 that we started with, and then our 1 minus our rate. So that would be written this way. You should simplify it and write it this way. 0.70 to the t. So that is our decay model. Now, how much is it going to be for 4 years? Well, 4 is going to be our t. So put that in. So y is 1,200, 0.70 to the fourth. You need to calculate this exponential portion first and then multiply by 1,200. That ends up being 288.12. Okay? Number 62. For some reason, my pages got off, but here's the start of number 62. You deposit $2,000 into an account that pays 2.75% interest, compounded monthly. So find the balance after 3 years. Okay, so this comes straight from our compound interest formula. I'm going to go ahead and get that written correct or shown correctly. So that would come just straight from our formula, our amount that we're going to achieve, and here's our principal. 1 plus our rate divided by the number of times it's compounded times the number of times compounded times the years that it's compounded. So this is our principal deposit, 0.0275. That's our rate. It is compounded monthly, so our N is 12. Find the balance after 3 years. So our T is 3 years. So you just simply plug all this information in. It's a straightforward plug into the formula. The thing you need to make sure that you do, and the thing that I keep seeing mistakes happening on, is you need to make sure, let's see, I guess I wrote that all out there this way. You know, you may want to keep this all in the calculator until the end, but, or just do it to 4 places. You need to make sure that you do this exponential part first. You have to do that exponential part first. Calculate this term to the 36th power and then multiply by 2,000. See, exponents, please excuse, and then my dear Aunt Sally. And so that ends up being an amount of 2171.79. Okay? All right, next page, number 63. We're dealing with our growth and decay model. This one, if you read carefully, is not saying continuously. It does give us a rate that we are increasing by. So remember that we have this, our population amount that we started with, 1 plus or minus our rate. So this would be y equals, and our population starts at 29,816,591, and 1 plus point, because it is growth, to the t. And so then you could go ahead and add that together. If you then want to go ahead and find that population in 2007, this would imply that our years are 17, because from 1990 to 2007, that is 17 years. So you take this initial population and you take your growth, or you take this here, find this exponential portion first in your calculator, then multiply it by the initial population, and that gives you an initial population, or a final population, of 37,013,552. So that many people. Okay, number 64. You deposit $2,500 in a high growth mutual fund. You've got this percentage rate. Annual, so that's 1 year or one time. Oh, so but this one we're going to do this compounded quarterly. So 12 years, there's my principal, there's my T. So it's pretty straightforward. 2,500, 1 plus my rate, divided 4 times over the course of 12 years. Do this portion first and then multiply it by 2,500. And so then that would make you 10,949.90. B is continuously. Well, what happened if it would just be continuously compounding? That would use our E model. And money usually doesn't compound continuously. Typically that's a science thing with physical, nature things. Okay, so calculate your exponential part first and then multiply it times 2,500, and you get 11,204.22. So there you go. That is the end of that. Now, I'm not doing the Chapter 9 material. That is on the Chapter 9 review. It came straight from that, so you can go ahead and look at that video.